Hi, welcome. Thanks for coming. So it used to be a talk, it's going to be a workshop. So please use your laptops. You can clone this repository. And the idea is, since when I'm doing it as a talk, I'm live coding. The idea is let's code all together. So when I'm live coding some stuff, you can do the same. Please ask any question you have during the talk or during the presentation. If you have any issue, please let me know. It's going to be some JavaScript. We are going to have a first version of the code and then refactor it towards something more functional. So you will need some JavaScript engine, Node.js, for example. And once you have cloned this repository, you will have a branch named T.A.K.E, which is the one you should start with. And once you have it, you should find the code a bit like this in the test folder. Okay? Go have a check at the test folder. And I'll let you a few minutes to get ready. Can you, once you have it and you're ready, can you just raise your hand so that I know it? And okay, that's one. It's awesome, but it will be at the very end. So if you don't have Haskell, it's not an issue. Don't worry for that, okay? JavaScript is enough. Like 95% of it is gonna be JavaScript, and the last 5% is just a way for me to prove you that it's functional because it's Haskell. Okay, so don't worry. And once you have it, so you have this code, can you also check that you can run the test and everything is green? So if you do something like npm test or that kind of stuff, should be enough. Mocha maybe? Yeah, no. If you just run npm test, should be enough. It fails, really. Interesting. Did you check out the branch T.A.K.E?
Yeah, no.
Please check out the branch T.A.K.E. The master indeed fails, but the branch T.A.K.E should pass.
Yeah.
Better? Awesome. So just so you know, the master is when I live code the imperative solution, and the T.A.K.E is with the imperative solution ready, which is where we are going to start from. By the way, can you hear me well in the back? Yeah? Any issues I can help, or do you have it all? You don't have Node.js? Yeah, you will need to install it then. And for you?
To connect to my virtual computer to have Git and everything.
Okay.
But it should be fine.
Okay. First. Is it working for you?
Install,
Uh, you,
I can do it on Windows.
yeah, you should be able to do it, but if you search on just install npm, you should find a binary to run. Yeah, perfect. Any will do. You choose. Yes.
The master. Should I start with? We'll start.
Yeah,
with
you
talk?
should start with talk. When you check out, you have it all. So. How is it going? Okay, perfect. Okay, so it seems that the only issue we have so far for most of you is you don't have Node.js installed. So some of you are installing Node.js. While you're downloading it and installing Node.js, I will explain you what we are going to do, and hopefully Node.js will be installed at that time, and everything should go smoothly. If not, if at some point I will ask you if everything is ready. If Node.js and you still have issues, please stop me so that we can all start from the same point. Okay, so by the way, I'm Xavier. I'm working for a company in France named Zenica, which is a contractor company. And I'm going to talk about functional programming. The idea is we are going to have some code which is written in imperative way. And the thing is, we are going to refactor this code to a functional way and introduce a lot of functional concepts while doing this. So it's a bit of an introduction on functional programming, but we are going to see a lot of things. The idea is to see each concept individually and add them up to go very functional. And you will see that actually, I'm pretty sure you know most of the functional things I'm going to talk about, but we are going to use it a lot to go towards functional programming. Okay, so we need a problem to solve, otherwise we would not be coding anything. So the problem we are going to solve is pretty simple. We have a list of movies, and we want to find all the movies that match title. So for example, if I search for Interstellar in that list of movies, I found nothing. So the list should be empty. Okay? But the second test says I'm searching for the movie matrix, and obviously I found it, so I get the whole movie in the end. And if I search for something like O, I should find the movie in Intouchable, which is a French movie, and Forrest Gump, because Matrix and Beautiful Mind does not contain the O. Easy. And if you run the tests, you see it pass, because I already have a first solution here. And this is a solution I'm pretty sure you all understand. What I do is first create an empty list, which is result. Then go through all the movies of my collection. If the title of the movie includes the query, the thing I'm searching for, then I add the movie to the result. Once I'm done with it, I return the result. And this passes the test. Okay? So any issue with that code? Everybody understands it, right? Okay. Now we are going to do some stuff with that code and start refactoring. Is everyone ready? Do you all have Node.js and the test going to green? Or do you need a bit of more time? Anyone stuck? Okay, so let's go. The idea is we are going to, yes, talk about functional programming, but not just for fun. We need a reason to do that. And the reason will be we are going to refactor our code and try to make it more readable. And if we find some issues on the way, then we will fix the issue. But first, let's talk about this style. This is imperative programming. I'm going to explain the computer what you have to do. Create an empty list, go through all the movies, then see if the title match what I'm searching, add it to the list, return it. That's very imperative. I'm explaining the computer what to do. And it's there is only one entry point to the whole code. And I'm sure you know already that I could do something like this. So have a function that returns the movie title. But now I'm not imperative anymore. I'm procedural. Because I have more than one entry point and I can reuse some entry points in my code. And I'm pretty sure you all know that this is pretty cool, so we are going to use it a lot. So please follow me with the refactoring on the code you have. So I just extracted the function title. Another thing which is pretty cool with functions like this is that if there is one name that you don't like include here, let's say I don't like it, I can extract it and give it another name. So for the whole expression, like title movie includes query, I can say I want a function that I will name matches. And for includes here, if I don't like the name of it, I can wrap it into another function and use the name I like. And since I'm a bit weird, I like is infix off. Okay? So that's some cool stuff we can do. Well, just for fun, because last time I talked with an architect, he told me that 2 levels of indentation is too much and you should have only 1. I can extract it to a function, let's name it add if matches. Okay, so I'll leave you the whole code refactored. And well, by the way, my test, as soon as I finished to change my code, the tests are going to rerun. So as soon as I finish refactoring, the test run. So if it's green, it means my refactoring is okay. Any questions so far? That's all things you know already. You knew that technique already. You knew I could do that, right? Nothing special. When you're done, please raise your hand so that I know you are done. 1. And by the way, don't hesitate to interrupt me. If I'm going too fast, please tell. Yeah. You can't refactor on JavaScript? Ah. Sorry for that. Take your time, don't worry. It's not a race. Do you have Node.js installed? Yes. If you run npm tests, it will run automatically every time you save your files.
Thank you.
So just keep a console aside from your code. Okay?
What's the branch?
The branch is T.A.K.E. How is it going? Yeah, it looks good to me. Finished?
I think we have finished copying the refactoring, but I'm not familiar with Node.js, so I don't know how to run
And
the test.
you need to run, not happy here, you need npm install before.
Okay.
So you need to turn out a bit of stuff. On
now it's installing the...
Exactly.
Okay.
It's
I have to-
installing Mocha, which is the thing you need to run your test. And then you run npm test,
It
should work.
Yeah, and I should do this at the location for the...
Yeah,
Right here?
yeah. Where you're right, I think.
Okay, okay.
So let's wait a bit and check with you that everything is working. It seems you were on the right branch.
Yeah,
So
I have downloaded it from that branch.
yeah. So now you should be able to npm test. And it passes. So and every time you will save your file, it will rerun it. So you just keep this console aside, and it will rerun every time.
Thank you so much.
You're welcome. Okay, it seems fine. Yeah, good for you too? Sorry?
Can't find shy.
Okay, I think you need to run
Yes.
npm install first.
I ran it.
You run it.
Yes.
Okay.
Something packages.
I'm installing Haskell now. I don't
No,
want
you
Haskell.
should not. You don't need Haskell.
Okay, I'm gonna install again.
And npm test. Interesting. Yeah, I think you are not on the right branch. You're on master, aren't you?
It's very possible.
Okay, so you need to use the branch talk. There is another branch
Okay.
named talk.
Great.
Thanks.
Okay, let's continue. So we did a bit of refactoring for our production code, and refactoring is great, but refactoring is not just for production code, it should be for tests too. And if you look at the test here, I have some duplication, right? My list, my collection of movie are always the same. So let's refactor it. We can extract this to a variable. Let's name it movies. Okay. So obviously this is not an issue. And then I'm going to change it on the second test to use movies too, on here too. So I moved the movies to the describe session and I use it in my test. Okay? And if you do that, you will see that 2 over 3 tests are failing. So we have an issue here because the refactoring was pretty simple. I just removed duplication using a variable, but I broke my tests. So let's try to find why. The issue we have is if you look at find by title, we are using here shift. So shift is a function that you can call on a list. And what it does is take the first element of the list, returns it, and removes it from the list. So now what's happened? Well, we run the first test, which empties the list, and the second test has an empty list to work on. So obviously it doesn't find anything. So this is what we call side effects. A side effect is when your function is going to change the value of an input you gave, or on something that is a hidden input you gave, something you didn't but actually did, like when you're writing on the console on JavaScript, or you're writing system.out.println in Java. Well, you didn't give the output where you should write because it's a global variable, but then you can say actually you did pass it to the function but didn't pass it explicitly. So when and you change the value of this. When you change what's inside the file, you change the file, right? So any side effect is when you change the value of the input of a function. And the bad news about side effects is that it's going to make the reasoning on the code harder. Like, we just saw it. I just refactor a bit of my code, remove duplication, everything breaks. Hard to understand, okay? Should not happen. So that's the bad thing about side effects, and that's one of the reasons we are going to avoid as much as possible side effects in our code when we are going to go towards functional programming. And one of the key things you should understand about functional programming is we don't want side effects. The bad news is for functional programming is we don't want side effects, which means we can't do anything actually, because if you don't have side effects, then you can't print anything on the screen, you can't write on the disk, you can't go on the network, you can't take inputs, on that kind of stuff. So actually, we can do a functional way to have side effects. It's outside of the scope of this talk, okay? But we can, just know we can. The idea is for now, for the exercise we are going to write, we try to remove as much as possible side effects by pushing it towards the limit of our system. That's the trick we use. Since we can't get rid of side effects, because if we get rid of side effects, then we are useless, and we want to be useful, we are going to push it as far as possible towards the limit of our system. And that's what we are going to try to do. Okay, let's fix our test by removing side effects. You can actually get rid of the while and use a for. And instead of equal, use off and remove the shift. And then you need a let here. And if you rewrite the line like this, then you don't have any side effects, because what for off is going to do is go through the collection as you're expected to do by not removing any value. Okay? Everyone is green? Yes? Okay. So we just saw that side effects are pretty bad. So we want to detect side effects, find a way to debunk it. The way we are going to do that is looking at the signatures of things. So let's get used to a way I'm going to write signatures for functions. The function title is a function that takes a movie as an input and outputs a string. Okay? The function is infix of is going to have a string, another string, and returns a Boolean. The function matches takes a movie, a string, and returns a Boolean. So far, so good. Now, the function add if matches is going to take a movie, a string, an array of movie, and returns nothing. And that's the proof we were searching for. If you have a function that is useful but is not returning anything, you know there is side effect in that function. There is no other way. You either return the thing you just did, or you're returning through the input, doing side effects. Okay? So Now we need to know if this function is really useful or not. The good news is we have tests, so we can know pretty quickly. Just remove the code, run it, it's read, the function is useful. So we have side effects. Okay? So, as soon as you see a function that is useful and that returns you nothing, you can say that you have side effects. And we are going to try to fix this because we saw side effects are bad. But this is not a silver bullet because remember find by title, we had side effects in it with the while. But if you look at the signature, find by title is taking a string, an array of movie, and returns an array of movie here. So it is returning something, but you can do side effects in it. That's the bad news. Even if you return something, you may do some side effects. And the only thing you can do with this is pay attention on what we are writing and try to avoid side effects with it. A nice way to do, to be sure you don't actually have side effects is check if you're calling any function with side effects in it. If not, you probably are not doing any side effects. If you looked at shift, it was a function that say I'm returning something but is doing some side effects. Okay, so we are going to try to fix the side effect here. But to do that, well, let's get it started. I need to introduce some functional concepts. The first one, and I'm pretty sure you know how to do it, is I can write something like let predicate equals matches. Okay? Do you all knew you can write this in JavaScript? Yes? Nobody surprised? Okay, but this is a big deal. This is a big deal because matches here is a function. And I'm not calling the function. I don't have the parenthesis. So what I'm saying here is inside the variable predicate, I save the function matches. The same way right before I said on the variable results, I saved the value empty array. In other words, I'm saying I'm handling values on functions exactly the same way. So it's pretty simple. And if you want to shine during a dinner or when you have a talk with friends, you are going to say that you're using a function that has functions as first-class citizen. That's the way we describe being able to do that. But that's it. You don't need more. Now, once you have this, since it's a variable here with predicate, you can say, well, I'm going to pass my predicate to the function add if matches. So I give it the predicate here. I have my predicate here. And I can use my predicate instead of matches. Still pass my test. Yes? Okay. So I'll let you do that. When you're ready, please raise your hand. So what we are doing here is we use functions as first-class citizen. to pass functions to another function. By the way, the function addIfMatches is actually not anymore addIfMatches, but addIf, because I could change the predicate here, and that the predicate saying matches. Good? Anybody stuck? Okay. So, by the way, we just pass a function to another function. When we do that, which we can because we have functions as first-class citizen, when we do that, we say that the function addIf is a higher order function. The only thing it means is it's a function that can receive another function as a parameter and or return a function. Another word to say it is a higher order function is the function that can deal with other functions. Okay. So that's also awesome. That's a trick. A lot of words useless because I didn't solve my issue, which is the side effect, right? Yes. Well, I will need to introduce another concept to solve the issue. And you will see it's very similar. So let's go back here and say, let's add equal a function that I'm going to call add, which takes a parameter which is a movie, and say result.push movie. Very similar than what we just did before with functions as first-class citizen, right? But it's not just another function. Because if you look at what I did, I'm using results here, which is not a parameter here to the function add. How can I use a variable if I don't have it as a parameter? Yes. So let's explain why we name it a closure. Another way we could write quite the same thing, but not exactly, is I could have a variable O, which is results, and use it here. Okay? What I'm actually saying here is I have a function with two parameters. The second one is O, and the default value of it is results. But then, when I call this function, I can say, here is the movie, and here is the array of movies you're going to use. But I don't want this here. I want my user to be forced to use results. There is no choice. Like, I want to have equals result. I want to be results. I want to force it. Okay? The only way to do that in JavaScript is just don't say it and use it. Okay? That's the same thing. But now, I have a hidden parameter, which is results, forced to be equal to results. So when I call it, I can't choose the value I'm going to give. When I can choose the value, we say that the parameter is opened. When the parameter can't be set, we say that the parameter is closed. Okay? So open to assignment and closed to assignment. And any function that has at least one parameter that is closed is named a closure. Okay? So, now, this is a closure, which is a function, and functions are first-class citizens. So, we saved it inside a variable, and we can use it and pass it to addIf. So, let's do that. And I can use add instead of result.push here. Still pass my tests. Okay? And by the way, let's rename the function to doIf, because now I can say this is the predicate, this is the action you will do, which is basically if, right? Okay. So this is all very cool, but we still have side effects. Indeed. But now I'm in a position when I can remove the side effect. Remember, I told you we are going to push side effects towards the limit of the system, and that is exactly what we are going to do. The function doIf is more inside the system than the function findByTitle, which is a bit outside. So now I declared the function add, which is doing the side effect. If you look here, what I'm doing is the function add takes a movie and returns nothing. So obviously there is side effects here. But this is a side effect at a better position than doIf. So I'm more okay with this one than with this one. So the trick here is I'm going to say findByTitle. I understand you want me to do some side effects, but I won't. I will let you do it. How are we going to do that? Well, don't call the method. Don't do it. Let the other one do it and return it. Now, on the other side, I will receive a function here. And I have to call it. So now, if I'm sure I will receive the function because I call it, then it means here I need an else, and I need to return a function. Return a function that do nothing and actually do nothing. Okay? By the way, this is the only method that you can write that is going to receive one parameter, returning nothing, and not doing any side effects. That's the exception. This is a function that is saying, I'm doing side effect, but actually is not doing side effect because it's doing absolutely nothing. You can write something more complicated than this, like I can say, let A equals 42 and A plus plus, but that's the same code. Okay, if I remove this, this is the same function. It's still the function that does nothing. Maybe it computes things, but in the end, it does nothing useful for my user. Okay, and once you have this, you should be green. And the good news is, you just remove the side effect because you are not doing the side effect yourself. You're letting, I'll show you a bit more here. You're letting the function findByTitle do the side effect instead of yourself. Is everything there? Is everybody there? Or do you need a bit more time? Okay. Any questions? Go ahead.
Can we remove some parameters now which are
Yes, we can. Indeed. Thanks. I forgot that. Indeed, we can remove the results because I don't use results. So yes. Oops. You can remove results. Should still work. But you still need the predicate, movie, query, and add. Thanks for that. We can also update a bit the signature here. So do it if you want, but it's not mandatory. Now we have a predicate that takes a movie on the string and returns a boolean. Had I messed up? Which takes a movie, a string, and a function that is taking a parameter which is a movie, doing some side effects, and this is the type I'm returning to. Okay? Everybody there? Any more questions? Well, since it's JavaScript, the answer is no. But if you had a language that checks for types, the answer would be yes. Because the function has to take one parameter. Okay, so we just moved the side effect, which is good. Let's have a look at the other side of the coin. Here, I have the keyword, the word add, which is duplicated. Here, I have the use of the parameter movie, which is duplicated. And here, well, let's be honest. It's way more complicated than before, isn't it? That's the biggest issue of the four. So we had one issue. Now we have four issues. Ugh. Okay, let's try to fix now the four issues we just discovered. The first one is the simplest one, which is add is duplicated. So there is a cool thing about duplication. When you need to remove duplication, well, remove everything until you have only one. So just remove the word add for the name of the function. Solved. Still pass my tests. So it looks like nothing, but that's a lot actually. Because now I have a function that doesn't have any name. And I will need to talk about this function to you, saying, look at the function I put inside the variable add. That's a long name to talk about this function. Okay? So a function that has no name, and we want to name it to talk with people about it, well, the word that we use is lambda. When we are saying this anonymous function here, actually we are talking about lambdas, so now I can tell you, look at the lambda or add, and now you know it's this that I'm talking about. This is the basis for lambda calculus, and lambda calculus is the basis for functional programming. So now that we have this, we can go a lot more deeper inside functional programming. By the way, I'm pretty sure that so far you knew everything I show you. Like putting a variable inside a function inside a variable, closures on lambdas, that kind of stuff. I'm pretty sure you knew it already. It looks like not such a big deal to have lambdas. Don't forget you need 8 versions of Java to have it. Okay? It's not so simple to implement actually. Okay, 3 problems. Let's definitely get rid of the side effects. So the trick is let's have a second parameter, which is going to be my collection, my movies, and use it, but don't push any value to it, use concat. When we concat 2 lists, we create a third list which contains the 2 lists we had before. So we avoid side effect because we don't change any parameter, which is great. So let's say I have movies here, and I do movies.concat, and I return this. Okay? So, of course, now the signature changed, so my test doesn't pass. I need to fix it. So, here, since I receive add, I need to call this function, which is add, with 2 parameters. The second one, which was result, so I give it result, and that's the return value is the new result. Okay? Still doesn't pass my test because I need here, since I changed the types here, saying I have movie on an array of movies, I have the same output. So now I need to align the types here, saying I have movies, and I return something that didn't change, which is movies. Trying to show you as much as I can, and should pass the test. Okay? So, good news is I get rid of the side effects. Bad news is it's even more complicated. Let's keep it for the end. We can play a bit more about lambdas, for example. I don't need the do nothing name here. The good news is here I don't have any side effects anymore because I'm taking 2 parameters, movie on movies, and return an array of movie. Yes? Do you all have your test that's all green? Are you all with me? Okay, let's wait a bit. Any questions? Is it all clear? Okay. Oops. So, what's your issue? It doesn't find matrix. Okay. Can you show me your code? Yeah, you need to say the result is equal to this. The new value of the result is the output of your function. So len 38, you say result equal this. Because you just created a new result, right?
Okay, so we didn't change this.
You
result.
don't change results anymore.
Okay.
We get rid of the side effects. Okay? Can you check it's green? Awesome. Okay. Everybody okay? Sorry?
What do you mean by moving?
I mean here, I'm giving to do if, I'm giving the word, the variable movie, and I'm giving it to the function here. You will see it's more visible if I inline the function here, which is going to be a bit crazy.
Right.
But on the same line, I have movie twice, which is kind of an issue, right? And that's the issue we are going to solve now. But to be able to solve the issue, let's be honest, I'm going to be a bit crazy. I will need you to bear with me a bit. Okay, let's go to the function add here. And instead of having a function that takes two parameters and return the concatenation, we are going to have a function that takes the first parameter, which is movie, and return another function, which is movies, and do the concatenation. I know it seems strange, but please bear with me. Now, I change the signature because now I have a function that takes one movie and returns a function that is waiting for an array of movies and do the concatenation. By the way, it's really common to do that in functional programming, so we don't use the parentheses because we really ask a function that takes two parameter, movie and movies, and return an array of movies. Now, my test fails. The reason it fails, well, is because I changed the signature. So I need to align my types. So I will do the same thing here, saying I return a function that takes two parameters. And now, finally, here, well, I have a function that takes a first parameter, which is movie, and returns a function that is waiting for the second parameter. So instead of using comma space, I use two parentheses to separate parameters. And I go green again. Okay? I'll let you see it if I can. Everybody there? So I know that's a bit crazy. But thanks to that, we are going to be able to remove the duplication here. Why? Because what we are going to do is in the function doIf here, I can say, well, I won't return add. Once I, by the way, sorry, here I forgot to say it's going this. Okay, and now I have a function that looks like this. So the thing is, I could say I'm not returning just add. I will return add with the first parameter given, which is movie. Okay? The consequence is, well, the type is now a function that is waiting for an array of movies to do the stuff. So I need to align my types here. And since I've done that, I can remove the parameter here. And I'm back to green. And I removed the movie duplication. Okay, I'll give you as much as can fit here. Yeah, you have it all. So I'm going to give the first parameter movie to the function add and return this. And use it here. So I just need one parameter here. By the way, another good news is since we remove one parameter, it's a bit less complicated. So since it's a step a bit crazy, I'll let you a bit more time to do it. Any issues or questions? I can see your face. I know you have issues. Please ask questions. Okay, I go check. So your test on red, right? There? Green.
There, I think so. I can inline functions like,
Yeah.
like this. So like this result.
Yes.
Here.
Yes.
I didn't know about this about
Exactly.
like,
Okay.
Okay. Thank you.
Awesome. How is it going?
Yeah, it's good. We're trying to understand.
Okay. Is it green?
It's passing, yeah.
Okay. Everybody okay? Any question? Is there anything you don't understand? Yeah? Okay. So, let's use some buzzwords. What we did here, we transformed one function with two parameters to two functions with one parameter. And as we just saw, because my tests are green, this is equivalent. I can do one way or the other. That's the same thing. Doing that is what we call currying from Haskell curry, which is the first one who wrote a paper pretty famous about doing this stuff. So the technique is named after him. Curry like the spice, but it's not the spice, it's the guy. Then, thanks to that, what we did is we gave the first parameter of the function add. We gave just the first, not the second. And since we get the first parameter, we receive the function waiting for the second parameter to work. Say another way, I gave some of the parameters of the function, but not all. That's what we call partial application. A full application or complete application is I give all the parameters the function needs to do the stuff, and it does it. Partial application is I give it some, and it's returning a function asking for the rest of the parameters. And thanks to partial application, we remove duplication in the find by title function. Okay? So it seems like currying is pretty cool, because if we curry everything, then we can do partial application with everything, right? So it's a bit like extracting functions, procedures. At the very beginning, we start doing it. It was awesome because the code is more readable, shorter, we understand things better, we can do more stuff with it. It's awesome, let's do it everywhere. We are going to do the same thing with currying because it's awesome, so let's do it everywhere. But before doing this, I will show you a bit of JavaScript tips. And the tip is, since the last version of JavaScript, which you all have since you are executing the code, you can write lambdas another way. Instead of using the keyword function, you remove it and you add an arrow between the parameters and the curly braces. And it still passes the test. So yes, you can do it here. Whoops. Also, the cool thing about this notation is that if you return, if the only line of your code, it's a one-liner, and the only thing it does is return something, drop the return and drop the curly braces. So you can remove this. And it still works. Obviously, you can do it for this one too. And it still works. But I will keep this one. And I will explain you why in a second. One last cool thing you can do with it is, if your lambda takes only one parameter, you can remove the parentheses, so you can write it that way. And the cool thing is, now I have a function that is curried, but in a way shorter and less verbose way. And a way more readable way. Why? Well, let's have a look here, okay? Which is the way of writing we are used to. Here I can read, I have a function that is named find by title, which takes two parameters that are query and collection, and is doing some stuff, which is the body inside curly braces. The good news is with add here, well, I can do the same stuff. If you squish your eyes a bit, here you can read function. This is a function that is named add, which takes two parameters, movie and movies, and is doing this body. Okay? So actually not too much strange. We just change the keyword and a bit of the syntax, but we have the same thing. Well, almost, because now we have curried functions, which we just say was awesome. And now that we know we can write it that way, let's do it everywhere. So let's go back to the top of our file and say, well, let title equals a function that takes one parameter, which is movie, and do that stuff. Still pass my test. I can do it here. Let isInfix of equal function that takes two strings and do that stuff. It breaks my tests. Why? Because now when I have a curried function, I need to call it a different way, which is instead of using comma and space like here, I need to use two parentheses, which is 2 characters versus 2 characters. So it's just a syntax issue, nothing more complicated. I'll let you some time to do it everywhere. So we can do it for matches. Which is called here. We can do it for do if. Which is called here. And finally, we can do it for find by title, which is called here. And of course, I need to change my call here in my tests. Takes a bit of time. I'll let you do it. Up. You're welcome. You have too much parentheses, I think. Yeah, around movie, you don't need that much of parentheses. And yeah, it doesn't, and you need one last at the very, no, here, indeed, yes, just one. Should be fine. That's better. You have a test that's fine, but at least in comparison. Yes, you curify matches, and matches is used here, right? So the way you call it is not currified, so you need to fix the comma space to two parentheses. So you close and you open. Yes. Awesome.
Okay.
I have a question. Why can't I write it this way?
Yes, you can.
Where it doesn't have the test.
You have some. You have too much curly braces. You had this one here. That was too much.
I had to remove
This, and you have to remove this one.
This was
Yeah.
because I have removed that and I forgot.
Yeah. So it should be green.
Okay.
How is it going? Fine? No issues? So you're receiving a function. So the thing is, if you go to the tests, I'm pretty sure go have a look at the test.
Where?
Your test. Scroll down. Yeah. Here, you need to call it with the currified way. So you have comma space here. You should have parentheses. Close the parentheses and open it. That's the way you, yeah. Do you see what I mean or not?
No.
Okay. If you look at the function find by title you just wrote, okay, your function is waiting for one parameter which returns the function that is waiting for the second parameter. You did it here. Instead of comma space, you use parentheses.
Oh,
Okay? But you need to do it in your test too, obviously. Okay? Yes. On this test is going to pass now. Should be. Yes. So you need to do it for all three tests, but you have it. Okay for you? Working?
Yeah.
Awesome. Great. One last find by title and you're there. Awesome. Good. Tell me when you're ready, okay? Everything okay, guys?
Yeah.
Good? Okay. Yeah? Awesome. So, now we currified everything. Thanks to that, we can use currification everywhere. Partial application everywhere, sorry. So, let's have a look here. My predicate is matches, but matches is curried, sorry. So what I can say is, well, I want everything that match the query. Okay? So now I have a function that is just waiting for a movie. Whoops. Wait a minute. As I remember, I forgot something. Yes. So one thing I forgot is we are going to change the parameter movie on query to have query first. The reason we are doing this is because we are going to use partial application. Okay? And we want to say, I want a new function that is going to say, given a movie, is it going to be okay or not? Because in the end, that's what I want to do. I want to sort out movies. Okay? So let's change the order. It's pretty simple to do. Query first. So since you have the query first, when you call it, we need to put the query first. So we have one change here on the signature of the method matches, on one change here when you call it. Okay? So yeah, you change
Yeah, we
matches.
changed the wrong one. So
On the wrong place?
yes.
Okay. You do if should not change. What should change is the way you call the predicate. Okay. So it was movie query. Now it's query movie here, which should be a functional way actually. So here matches should be more curried. So you forgot to curried matches.
Oh,
Okay. Good for you? Working? Just okay. So now that we have the parameters in the right order, sorry about that, we can say what I want is the predicate that match a given query. Okay? Now I have a function. The signature of the predicate is give me a movie, I will give you a Boolean. So here, we don't need to give the parameter query anymore because we gave it before. So we can remove this parameter and the test should go green. So please add the parameter here and remove it here. Thanks to that, now we don't need this parameter query and we can remove it here. We are getting there. One parameter at a time. Okay? So, one last thing. Let's switch these two lines because if you look at the code here, you could say, well, let's extract this in a function that we are going to name filter. Okay? And I want to say I'm going to filter a predicate on a collection. So let's switch the order. I want predicate first and collection after. Okay? So I want to filter predicate collection. And of course, since we have filter now, we can say that we want it curried, sorry for my French, and call it a curified way here. But guess what? The function filter exists in JavaScript. So instead of doing all that complicated stuff here, what we can say is I have collection.filter predicate and remove all this mess. And I can even remove the doIf function. And I put it filter a bit up there. I will inline the predicate here. And you should have something that looks a bit like this. So, this will be the last refactoring I will ask you to do, because when you've done this, you will be pretty functional in the way you code it. Good for you? Yeah, you need to purify everything. It should not change the filter thing, but on your code here. The way you call the function, you put comma space, you should have parentheses, parentheses. Close the parentheses, open the parentheses. Yes, yes. Can you remove your parentheses here of title? Just to be sure. It should not change anything, but just to be sure. So a read property includes of undefined. You have undefined. Interesting. You have the movie. Yeah. Matches. Okay. Matches takes a query. Yeah, matches you should revert. Matches is taking a query on the movie and do the stuff. So you need to switch movie and query.
You're moving pretty fast.
Yeah, I'm sorry. Short on time. Yeah, better.
Thank you.
Good for you? Yeah? Okay. So that was the last refactoring. We are running a bit out of time. So I will be very fast because I have to do it in 2 minutes. So basically, the thing is all these functions here are either already existing in the language or pretty trivial, right? The first one is just return a field of an object. The second one is renaming a function that exists. The third one is querying a function that exists. So all the business of my code is in these two functions. We can even say better. We can say all the code of all my business code is in these two lines. Okay? Now, this is a very functional way to write code. And I will prove it to you. So there is a language that you may have heard of, which is Haskell. Okay? Haskell is a purely functional language. You have only two ways to write Haskell. You either write it a functional way or you don't write it at all. So if I write something in Haskell and it compiles, it's guaranteed to be functional. By the way, this is a statically typed language, so I can't just create object like I did in JavaScript. So I need a type movie which contains a title, which is a string, a year, which is an integer, and I can print it to the screen and test on equality. Now, here you will find the tests we have in JavaScript written in Haskell. And I could write run Haskell. Okay, and it's saying, I don't know what you're talking about because I don't know find by title. Okay, so let's have fun. Let's copy paste this into Haskell. Okay, now Haskell has a different way to have comments, double dash. Since the only thing you can declare is a variable, you don't need the keyword let. Okay, we don't use double arrows but single arrows. And finally, we are explicit about lambda. So a lambda, the character is like this. If you look at your keyboard, you will take some time to find the character lambda. So they find another way to do it, remove this leg, and you have backslash, which is pretty fine to find on your computer. So we add backslashes here. And I messed up. Wanted to go too quick. What? Two tests that passed, the third one not. Not the first time it happens to me. Pretty interesting. Is it passing in JavaScript? It does. It's query collection. I'm not reading the right one. So match query collection is in fix of title movie. Ooh, yeah. Sorry for that. In Haskell, the parameter infix is infix of is the other way, so I have to write it like this. Better. Sorry. So that was the proof. It's very functional. By the way, just a bit of Haskell goodness. Writing lambdas like this is a bit tedious. So we can use syntactic sugar here. Was it like this? Yeah. Oops. I'm messing up here. So query on movie. Query on movie. On here. Query on collection. Query collection. And finally, it's statically typed, so we can say the signature of function, which will be checked. I'm sorry, I'm rushing it. And finally, so this should run. What? I'm trying to go too fast here. What did I mess up? What? Okay. Thank you. Collection is a. So let's go back a bit. Okay, this should run. Yes. Now I have query here on collection. I should be able to remove this. Should pass. Yes. Now, for the types, find by tensor, staking a string on the movie, pass. Matches, staking, a string first on the movie. Yes. Okay. No. We don't need semicolon in the end of the line in Haskell. So we can get rid of this. And when we want to pass parameters to function in Haskell, we use spaces. We use parentheses only if we want to say this function call, the result of it is the parameter. So like here, for example, continue to pass my test. Okay, so we went from JavaScript, refactor it a functional way, copy paste it to Haskell, almost worked. So that was a very functional way. Now the code you have on your laptop is very functional. And we used only concepts that you almost already know, which are functions as for first-class citizen, which introduced a higher order function. Then we introduced closures. Thanks to that, we were able to have currying, because currying is just using higher order functions, closures, and functions as first-class citizens. Thanks to that, we had partial application, and we were able to do all that. So it's just things you already knew, used a lot. Now, maybe you want to learn a bit, hopefully, about functional programming. You want to try it at home a bit and want to learn more and go deep in functional programming. You could choose a language that has two paradigms. One is functional, the other one is usually object, like Scala, Kotlin, that kind of languages. They are called multi-paradigm languages or impure functional programming languages, because you can do side effects in it. Okay. Same goes with closure, which allows you to do some side effects, F-sharps or such languages. They are all fine languages, okay? If you can use it at work, please use it. But if you want to learn, when you are going to code in that language, You may have issues because you're trying to learn something. And if you have issues, you're going to say, I want it to work. So you're going to fall back to what you know and use the other paradigm or the side effects or the bad things in the functional way of thinking. So the idea is, if you want to learn, I highly recommend you to use a purely functional language. Haskell is one, ELM is another one, and Idris is another one, harder one, but is another one. Please use such a language to learn functional programming. Once you master this, go to another language like Scala to choose when you want to have functional programming and when you want to have object-oriented programming. Thank you very much.